Hello, am I audible?
Yes, sir.
Thank you, Amma. Phenols. Preparation methods of phenols. Dow's process. We have discussed in nucleophilic aromatic substitution reactions or properties of chlorobenzene. Chlorobenzene on treating with fused sodium hydroxide at 300 atmosphere pressure and 625 Kelvin temperature. Cl minus nucleophile will be substituted with OH minus present in the base, and phenol it is acidic in nature, so that acidic proton will be replaced by the Na plus, so it gives sodium phenoxide. ఈ సోడియం ఫినాక్సైడ్ను ఆమ్ల సమక్షములో జల విశ్లేషణం చెందించిన H3O ప్లస్ ఫినాల్ ఏర్పడుతుంది. Next, second method from benzene sulfonic acid. బెంజీన్ను ఓలియంతో చర్యనొందించినట్లయితే ఓలియం ఈజ్ mixture of sulfuric acid and sulfur trioxide. So mixture of sulfuric acid and sulfur trioxide is oleum H2S2O7. Benzene undergoes electrophilic aromatic substitution with oleum to form benzene sulfonic acid. Benzene sulfonic acid treated with sodium hydroxide. This acidic proton is replaced by the Na plus. It gives sodium benzene sulfonate SO3Na. Now sodium benzene sulfonate on treating with NaOH fused NaOH. It gives sodium phenoxide. Sodium phenoxide on acidic hydrolysis. It gives phenol. సో మనకి ఎగ్జామ్లో డైరెక్ట్గా ఇక్కడి నుంచైనా అడగొచ్చమ్మా, ఇక్కడి నుంచైనా అడగొచ్చు. అంటే బెంజీన్ కెన్ బి టేకెన్ యాజ్ రియాక్టెంట్ ఆర్ బెంజీన్ సల్ఫోనిక్ యాసిడ్ కెన్ బి టేకెన్ యాజ్ రియాక్టెంట్. See this first reaction. Benzene on treating with oleum gives benzene sulfonic acid. You have studied in the first year under electrophilic aromatic substitution reactions of benzene. Now, see conversion of benzene sodium sulfate to sodium phenoxide. This reaction is an example of SN2 reaction. SN2 type of nucleophilic aromatic substitution reaction. Third method from benzene diazonium chloride. This we have discussed while discussing SN1 type of nucleophilic aromatic substitution reactions. What are the compounds which undergo SN1 type of nucleophilic substitution reactions? Do you remember? Benzene diazonium chloride or benzene diazonium salts. Benzene diazonium chloride, in the place of N2 plus, we should get OH minus. So treated with water. Product is phenol. What is the type of mechanism involved in it? SN1 type. Right? Now, sorry. Another one from cumene. Cumene hydroperoxide. See, this method is industrial method. Industrial method for the preparation of phenol. Now, what is cumene? Cumene is isopropyl benzene. Cumene is isopropyl benzene. Now, CH3, CH3. How can we get isopropyl benzene from benzene? This reaction you have studied in the first year under electrophilic aromatic substitution reactions of benzene. It's a name reaction. Friedel-Crafts alkylation. Friedel-Crafts alkylation. See, benzene, when it is allowed to react with propene in presence of phosphoric acid H3PO4, or we can take any Lewis acid. This reaction is an example of electrophilic aromatic substitution reactions. Right? This isopropyl benzene is nothing but cumene. Now, see what is the ultimate product? Phenol. Ultimate product is phenol. Finally, we should get phenol. So, to get phenol, oxygen should be introduced, right? So, that introduction of oxygen is possible with aerial oxidation. Air present in atmosphere, it interacts with the isopropyl benzene or cumene, right? So this process is called aerial oxidation. గాలిలోని ఆక్సిజన్తో ఆక్సీకరణం చెందించబడుతుంది. Now, see this oxygen oxidizes cumene into cumene hydroperoxide. See carbon, oxygen, oxygen, hydrogen. So O2, it undergoes homolytic cleavage and reacts with this isopropyl benzene. CH3 taken twice. This is called cumene hydroperoxide. Now cumene hydroperoxide is treated with dilute H2SO4. Right? Because this oxygen should be bonded to the benzene ring carbon. So that this compound is protonated. This compound is protonated. On protonation, it gives phenol. Byproduct is acetone. CH3, C double bond O, CH3. So isopropyl group will be oxidized to acetone. Benzene will be oxidized to phenol in presence of dilute SO4. Right? So in the examination, question may be given from cumene hydroperoxide as a starting material or reactant, or from isopropyl benzene or cumene, or from benzene. Right? Now, see the same reaction, it may be represented in single step. See benzene. First, it is treated with which reagent? Propene. In presence of H3PO4 followed by heat. Right? And second reagent. Second reagent is aerial oxygen. So, it may be represented as air or O2, aerial oxidation. Third reagent is dilute H2SO4. So final product is phenol is major product and byproduct is acetone. Right? So here we have discussed each step as an individual reaction. So in the examination, reactant may be benzene, propene, or reactant may be cumene or isopropyl benzene, or reactant may be cumene hydroperoxide. right? Or the same reaction can be represented in a single step like this. Now let us see the mechanism. See, you know the electrophilic aromatic substitution reaction mechanism, that is, see, from H3PO4 H plus will be generated. This H plus it undergoes electrophilic addition with the benzene. Isopropyl carbocation is electrophile. H plus will be added to this carbon, terminal carbon. Then middle carbon is losing electron density, so it gets positive charge. This is electrophile. Now this electrophile reacts with the benzene. Product is isopropyl benzene. See this isopropyl benzene, it is allowed to react with oxygen, right? Aerial oxidation. See oxygen, it is O double bond O. So one bond it undergoes homolytic cleavage that results oxygen radicals. These oxygen radicals they attack at secondary carbon hydrogen bond. Secondary carbon hydrogen bond, right? I'll write here clearly. See, this is one oxygen radical. This is another oxygen radical. Now, this carbon hydrogen bond also undergoes homolytic cleavage. One electron it interacts with this one radical. Another electron interacts with this another radical. So, in between carbon and hydrogen, oxygen is present. This step is oxidation because oxygen is added to the isopropyl carbon, right? So C CH3 CH3 here, oxygen hydrogen, right? Cumin hydroperoxide, cumin hydroperoxide. Now this cumin hydroperoxide, how it converts into the phenol and acetone. This is important because rest part already you have studied so many times, right? This is electrophilic aromatic substitution. You have studied in the first year. And reaction of radicals with the molecules. This also you have studied while studying halogenation of alkanes, right? Now, see this part is new part from here. Cumin hydroperoxide, how it converts into phenol and acetone. Sorry. See what we have taken here after this H3PO4, sorry, dilute H2SO4. Dilute H2SO4, it is protonating acid. So H plus will be generated from the dilute H2SO4. That H plus it interacts with the one of the two lone pairs with the oxygen. That results oxonium ion. CH3, CH3, O, OH. This oxygen is interacting with the proton from H2SO4, dilute H2SO4. It converts into the oxonium ion. Now, see this benzene ring pi bond electron density will be transferred to this oxygen. Then H2O comes out, right? Now it gives, see benzene ring is losing electron density. So benzene ring, it gets positive charge. That is erinium ion or phenonium ion forms. That positive charge, first it forms over this carbocation. Then it undergoes delocalization around these 5 carbons of benzene. We can represent this erinium ion resonance hybrid structure. Now new bond is formed between benzene carbon oxygen, and a bond is present already, it was there, that is in between isopropyl carbon and benzene carbon, right? Now in the next step, see this carbon, isopropyl carbon and benzene carbon bond cleaves. That electron density will be donated into the benzene ring. Then positive charge in the benzene ring will be nullified. This bond, isopropyl carbon bond and benzene ring carbon bond, does not exist in the next step. O, CH3, CH3. This carbon is losing electron density, it gets positive charge. Now in the next step, see water is one of the byproducts here. This water molecule or reaction medium water molecule, it interacts with carbocation. So OH, H. Oxygen, it donates its one of the two lone pairs to this carbocation carbon. See this benzene ring, I want to write it as pH. So pH, next oxygen, right? Oxygen is bonded to isopropyl group. Now, isopropyl, the secondary carbon is bonded with water oxygen. Oxygen is losing its electron density, it gets positive charge, right? See, now one of these two hydrogens, see sorry, here, see this electron density or this electron density will be transferred to the positively charged oxygen, right? Then this hydrogen, it comes out as H plus. That H plus, it interacts with this oxygen, right? So this oxygen gets a positive charge. I'll write the structure in the next slide. See here, pH, O, C, CH3, CH3, this is OH, and here hydrogen with positive charge, right? Now formation of this compound from this one, this oxonium ion, it is a reversible reaction. It is a reversible reaction, right? Now in the next step, see, one of the two lone pairs on oxygen will be transferred here, right? Now this oxygen gets positive charge. And this carbon valence exceeds 4. To maintain tetravalency, this electron density goes to the O plus. Then here it gives phenol plus CH3, CH3, OH plus. Now in the next step, this electron density transfers here. H plus comes out. So whatever the H plus involved in the first step, it comes out here. Finally, it gives acetone. CH3, C double bond O, CH3. Right? So phenol and acetone are products. This is the mechanism. Suppose if a question is given that in the preparation of phenol from benzene, in the preparation of phenol from benzene, what type of reaction mechanisms are involved? See, with the first reagent, electrophilic aromatic substitution. Second reagent, free radical oxygen or oxidation. Second reagent mechanism is free radical oxidation with aerial oxygen, right? Now third one, it is protonation, that is acid base reaction, Lewis acid base reaction, right? After Lewis acid base reaction, remaining are rearrangement reactions, right? Clear? See, first one is electrophilic aromatic substitution of benzene with propene in presence of H3PO4. Electrophilic addition, that is cumene, sorry, isopropene with H plus is electrophilic addition. So electrophilic aromatic substitution, and another step is electrophilic addition, right? Next one, see here. Oxygen is undergoing homolytic cleavage to form radicals. So free radical oxidation, right? Next steps are internal rearrangements. So this is the mechanism of phenol and acetone by cumene hydroperoxide. Clear? These are preparation methods of phenol. Now let us discuss properties of phenol. See, phenol actually it is colorless liquid, but it appears as a brown color. Why it is so? Because phenol it undergoes oxidation into quinone. Due to formation of quinone, phenol it appears as a brown color. See, phenol it undergoes oxidation with aryl oxygen. This is quinone. So due to formation of quinone, it appears as brown. Right. Next one is the smell of phenol. It is called phenolic odor. Right. Next property. See, phenol, its common name is carbolic acid. The same common name is used for commercial purpose also. So it is also commercial name. Then why it is called carbolic acid? Because phenols are acidic in nature. Phenolic hydrogen is acidic in nature. Right? So what type of reactions we have studied to find out acidic nature of alcohols? One is reaction with metals, another one is reaction with sodium hydroxide base. Similarly, phenol also allowed to react with sodium metal. So phenol, when it is allowed to react with the sodium metal, it gives sodium phenoxide and liberates hydrogen gas. So we can observe effervescence of hydrogen. And same phenol, it is allowed to react with sodium hydroxide. When it is allowed to react with sodium hydroxide, it gives Sodium phenoxide byproduct is water because OH minus and H plus comes out as water. Right? Now, phenol when it is allowed to react with sodium bicarbonate. What could be the product? What could be the product? See here. Phenol is acid, sodium is base. Phenol is acid, sodium hydroxide is base. Now, phenol with sodium bicarbonate salt. Here, sodium metal is clearly basic in nature. Sodium hydroxide is clearly basic in nature, but sodium hydroxide is salt. So, sodium bicarbonate. Sodium bicarbonate on hydrolysis, it gives sodium hydroxide and H2CO3, carbonic acid. H2CO3, carbonic acid, right? Now, so it is a salt of strong base and weak acid. Weak acid. See, always a reaction takes place from strong to weak, right? So reagent should be strong. Reagent should be strong. Then only reaction is possible from reactants to products. But here H2CO3, H2CO3, it is more acidic than that of phenol. H2CO3 is strong acid than that of phenol. So in products, strong acid is forming. In the reactants, there is weak acid. Weak to strong is not possible. Strong to weak is possible. So this reaction is not possible. Clear? Now, see what we have discussed while discussing nucleophilic aromatic substitution reactions. If we introduce electron withdrawing groups, they stabilize conjugate base. What is the conjugate base of phenol? Phenoxide ion. So in phenol, if we introduce one electron withdrawing group at ortho position, that is NO2, because electron withdrawing groups, they stabilize the conjugate bases, right? Now this is allowed to react with sodium hydroxide or sodium bicarbonate. NaHCO3. Scientists observed that reaction is not possible because orthonitrophenol is also less acidic than that of H2CO3. So H2CO3 is less acidic. Sorry, it is more acidic than that of orthonitrophenol. Orthonitrophenol. So reaction is not possible. See, one more NO2 group is introduced. Orthoparadinitrophenol. So there are two NO2 groups. Then the conjugate base is stabilized. When conjugate base is stabilized, reaction is possible. Right? So what is the product? ONA, and at ortho position there is one NO2 group. At para position there is one NO2 group. Why? Because orthopara dinitrophenol is more acidic than that of carbonic acid. Orthopara dinitrophenol is more acidic than that of carbonic acid. Right? Now, suppose if we take trinitrophenol, when dinitrophenol can give the reaction, trinitrophenol also gives. Right? Reaction is possible. Same products will get here. In the place of phenolic proton, there will be sodium. Clear? Now, almost all reactions of phenol you have studied in electrophilic aromatic substitution reactions under electron releasing group benzene. Benzene containing electron releasing group. Right? Now, let us see alkylation reactions. In alcohols, we have studied alkylation with ROH groups. The same reactions we'll discuss here with the phenol. So, alkylation. See, first reaction.
Sir, once again repeat the 8th page, sir, please.
ఏంటమ్మా?
Sir, 8th page repeat చేయరా?
ఏం రిపీట్ చేయాలి 8th పేజ్లో?
అవి ఎవరు? ఒక్క నిమిషం ఆగవాడు. ఆగడు. స్క్రీన్ షాట్ తీసుకోవాలి. ఆగరు ఒక్క నిమిషం. Okay, sir, continue the class, sir.
Okay, thank you, Amma. Now, see phenol. Alkylation reactions are nucleophilic substitution reactions. So, phenol, is it good nucleophile or poor nucleophile? It is poor nucleophile because it is neutral. If we convert it into the negatively charged nucleophile, how it is possible to convert it into negatively charged phenoxide ion? By treating with a base. OH minus, it interacts with the acidic proton, H2O comes out, then it converts into the phenoxide ion. That phenoxide ion is a good nucleophile because there is negative charge and it attacks on alkyl halide like methyl halide from the back side. So it is SN2 reaction. Then CH3 group, it bonds with the oxygen of phenol. The product is OCH3, methoxybenzene, right? So alkylation occurring over oxygen. So these reactions are O alkylation reactions. O alkylation means alkylation on phenolic oxygen. Now, what we have to take, suppose the phenol without converting into the phenoxide to get methyl phenyl ether or methoxybenzene. ఫీనాల్ను స్ట్రాంగ్ న్యూక్లియోఫైల్ ఫీనాక్సైడ్గా కన్వర్ట్ చేయకుండా అల్కైలేషన్ జరిపించాలంటే ఏ రియేజెంట్ను తీసుకోవాలి? పూర్ న్యూక్లియోఫైల్స్ ఉన్నప్పుడు ఏం తీసుకోవాలని చెప్పాను? అయోడిన్. సో హాలోజన్ బదులు అయోడిన్. సో అయోడిన్ తీసుకున్నట్లయితే అయోడిన్ ఈజ్ ఎ గుడ్ లీవింగ్ గ్రూప్. సో whatever the phenoxide ion is present in the reaction medium, that is enough to carry out the nucleophilic substitution reaction, right? Then product is methoxybenzene. Methoxybenzene, right? And what we have discussed, another reagent, that is dimethyl sulfate. So whatever the reactions we have studied under alcohols for alkylation, the same we will discuss here, right? Only reactant is different, that is phenol. So dimethyl sulfate, CH3 taken twice, SO4, right? Now, this reaction is carried out in presence of base OH minus. So OH minus, first it reacts with the phenolic hydrogen, then it converts into phenoxide strong nucleophile. That nucleophile attacks on methyl groups from the back side. So it is SN2 reaction. Here also SN2. Here also SN2. Right? Now, what is the product? Methoxybenzene. 2 moles. Now, another reagent, diazomethane. Phenol, when it is allowed to react with CH2N2, right? Then it gives OCH3, methoxybenzene and nitrogen. See, mechanism right on your own, because I have given the mechanism while discussing the same reaction, alkylation with alcohols, ROH. ఇక్కడ ROH బదులు ఏముంటుంది, ఫినాల్ ఉంటుంది, రైట్? మెకానిజం ఈజ్ హోంవర్క్, ట్రై చేయండి. నెక్స్ట్, O acylation reactions. What are the reagents we have used for acylation? Or in general, what are the reagents, acylating reagents? Acid chloride. Another one is acidic anhydride, right? So phenol gives O acyl product with acid chloride in presence of NaOH. Or another reagent is anhydride, carboxylic acid anhydride, RCO taken twice O, right? This is O acylation. Next, see, nucleophilic substitution reactions also we have discussed, but reactant we have taken chlorobenzene. Now, in the place of chlorine, let us take phenol, OH. Nucleophilic substitution reactions. So, phenol, when it is allowed to react with NH3. From NH3, what is the nucleophile we will get? NH2 minus, right? So this is possible with cupric oxide at high temperature and high pressure. Then product is aniline or aminobenzene, right? Now, let us discuss electrophilic aromatic substitution reactions. These reactions also you have studied under benzene, right? See, OH group, is it electron releasing group or electron withdrawing group? Oxygen electronegativity is more. Electronegativity of oxygen is greater than that of carbon. So it is
EAS full form ఏంటిది సార్?
electrophilic aromatic substitution. Electrophilic aromatic substitution.
Thank you, sir.
Welcome, Amma. So, due to more electronegativity of oxygen than that of carbon, it takes out the electron density, so it is minus I effect group. But on oxygen, there are lone pairs. These lone pairs, right? Lone pairs are in conjugation. They are in conjugation with pi bonds of benzene. Pi bonds of benzene. So, with respect to this property, oxygen, it acts as plus M effective group, and we can observe positive resonance plus M. So in inductive effect and mesomeric effect or resonance effect, resonance is dominating. So we consider resonance. Therefore, OH group is electron donating group, electron donating group or electron releasing group, right? If electron donating group or electron releasing group is present, reactions, I mean electrophilic substitution takes place at ortho position, at para position, and this are at ortho position. Clear? Because see, one of the two lone pairs present on oxygen will be donated into the benzene ring. Now, this carbon gets a negative charge. In the next step, this negative charge will be donated into the benzene ring. Now this carbon gets negative charge. In the next step, see, this negative charge will be delocalized here. Now this carbon gets negative charge. So negative charge is formed over uh, ortho position and para position, right? Ortho position and para position. So electrophile attacks at ortho positions and para positions. So electron releasing groups or electron donating groups, they are ortho para directing groups, because incoming electrophile attacks at ortho position and para position. So in phenol, OH group is also an example of ortho para directing group. This is one condition. Now, second important thing is, under normal conditions, నార్మల్ కండిషన్స్ అంటే ఏంటి? అంటే ఎలక్ట్రోఫైల్ అవైలబిలిటీ తక్కువగా ఉన్నప్పుడు, రైట్, ఒకవేళ రియాక్షన్ని రూమ్ టెంపరేచర్లో క్యారీ అవుట్ చేసినప్పుడు, అండర్ నార్మల్ కండిషన్స్ ప్రోడక్ట్స్ ఏమొస్తాయంటే ఆర్థో ప్రోడక్ట్ కానీ పారా ప్రోడక్ట్ కానీ. అంటే ఆర్థో సబ్స్టిట్యూటెడ్ ప్రోడక్ట్, ఆర్థో సబ్స్టిట్యూటెడ్ ప్రోడక్ట్, ఇది ఫినాల్, ఇది ఎలక్ట్రోఫైల్, రైట్. తర్వాత పారా సబ్స్టిట్యూటెడ్ ప్రోడక్ట్, ఇక్కడ ఎలక్ట్రోఫైల్, ఈ అంటే ఎలక్ట్రోఫైల్ అమ్మా, రైట్. నెక్స్ట్ అండర్ విగరస్ కండిషన్స్, అండర్ విగరస్ కండిషన్స్, విగరస్ కండిషన్స్ అంటే ఏంటి? హై టెంపరేచర్ హై ప్రెషర్, ఈ హై టెంపరేచర్ హై ప్రెషర్ లేదా ఎలక్ట్రోఫైల్ అవైలబిలిటీ ఎక్కువగా ఉన్న కండిషన్. హై టెంపరేచర్ హై ప్రెషర్ లేదా ఎలక్ట్రోఫైల్ అవైలబిలిటీ ఎక్కువగా ఉన్నది, రైట్. ఈ కండిషన్స్లో ఆర్థో పారా సబ్స్టిట్యూటెడ్ ప్రోడక్ట్ ఏర్పడుతుంది. అంటే ఈ రెండు ఆర్థో పొజిషన్లో ఎలక్ట్రోఫిలిక్ సబ్స్టిట్యూషన్ జరుగుతుంది, పారా పొజిషన్లో కూడా ఎలక్ట్రోఫిలిక్ సబ్స్టిట్యూషన్ జరుగుతుంది. ఇది విగరస్ కండిషన్లో, రైట్. సో ఎలక్ట్రోఫైలిక్ రియేజెంట్ ఏది ఇచ్చినా కూడా మీకు ఆల్రెడీ ఐడియా ఉంది. అంటే ఇప్పుడు హాలోజినేషన్లో ఏం వాడతాము? Cl2 క్లోరిన్ లేదా బ్రోమిన్ లేదా అయోడిన్ ఇన్ ప్రజెన్స్ ఆఫ్ లూయిస్ యాసిడ్. అదే నైట్రేషన్లో ఏం వాడతాము? HNO3 H2SO4. సల్ఫోనేషన్లో H2SO4. ఫ్రీడల్ క్రాఫ్ట్స్ అల్కైలేషన్లో అల్కైల్ హ్యాలైడ్ విత్ లూయిస్ యాసిడ్. ఫ్రీడల్ క్రాఫ్ట్స్ ఎసైలేషన్లో ఎసైల్ క్లోరైడ్ ఆర్ ఎస్టిక్ అన్హైడ్రైడ్స్, యాసిడిక్ అన్హైడ్రైడ్స్ విత్ లూయిస్ యాసిడ్. వీటి నుంచి వచ్చే ఎలక్ట్రోఫైల్ సెల్స్. మీరు ఏం ఐడెంటిఫై చేయాలి? రియాక్షన్ కండిషన్స్. అవి నార్మల్ కండిషన్సా విగరస్ కండిషన్సా? ఇవి ఐడెంటిఫై చేస్తే ప్రోడక్ట్ మీరు ఈజీగా రాయగలుగుతారు, రైట్. సో ఒకసారి టెక్స్ట్ బుక్లో చదవండి, చదివిన తర్వాత ఆ రియాక్షన్స్ డిస్కస్ చేస్తానమ్మా. ఇవన్నీ కూడా రివిజనే, కొత్తగా ఏం నేర్చుకోవట్లేదు మనము, రైట్. సో దీంతో ఆల్కహాల్స్ ఫినాల్స్ చాప్టర్ కంప్లీట్ అవుతుంది. సో దీని మీద నేను మండే రోజు కొన్ని క్వశ్చన్స్ డిస్కస్ చేస్తాను, ట్యూస్డే కొన్ని క్వశ్చన్స్ డిస్కస్ చేస్తాను. మీరేం చేస్తారంటే ఈ ఆల్కహాల్స్ ఫినాల్స్ చాప్టర్ చదవండి ఈరోజు రేపు, ఈరోజు సాటర్డే రేపు సండే చదవండి. మండే రోజు ఈ ఎలక్ట్రోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్స్ డిస్కస్ చేసిన తర్వాత కొన్ని క్వశ్చన్స్ డిస్కస్ చేస్తాను. అట్లాగే ట్యూస్డే కొన్ని క్వశ్చన్స్ డిస్కస్ చేస్తాను. ఓకే, ఎవరికైనా డౌట్స్ ఉన్నాయమ్మా? మీరు ఏం చేస్తున్నారు? 6th పేజ్ అని అడుగుతున్నారు.
సార్ క్వశ్చన్ ఆన్సర్స్ ఎప్పుడు ఎక్స్ప్లెయిన్ చేస్తారు? మండేనా
మండే,
ట్యూస్డే?
మండే అమ్మా. మండే రోజు ఈ రిమైనింగ్ రియాక్షన్స్ డిస్కస్ చేసిన తర్వాత క్వశ్చన్స్, అట్లాగే మిగిలిపోయిన క్వశ్చన్స్ ట్యూస్డే కంప్లీట్ చేస్తాను. ఓకే, థ్యాంక్ యూ అమ్మా, థ్యాంక్ యూ వన్ అండ్ ఆల్.
థ్యాంక్ యూ సార్.